Hello friends, today we will discuss the contour integration of type 2. In type 2, we will discuss the integration of a function of sin theta and cos theta from 0 to 2 pi. Okay. So for these types of integration, we will put the values z is equal to e to the power iota theta. This is the unit circle centered at origin of radius 1 and traversed it counterclockwise. Okay. We know that e to the power iota theta is equal to cos theta plus iota sin theta, and e to the power minus iota theta is equal to cos theta minus iota sin theta. From these two equations, we find the value of cos and sin. Okay, let's check it. Cos theta is equal to 1 by 2 z plus 1 by z, and sin theta is equal to 1 upon 2 iota z minus 1 by z. Okay. So putting these values in this equation, we find the integration of fz dz along the contour C, where C is the unit circle centered at origin of radius 1. Okay. Now we will solve this question of contour integration. Okay, let's check it. Apply calculus of residues to prove that integral of cos 2 theta upon 5 plus 4 cos theta from 0 to 2 pi is equal to pi by 6. Okay, so we will put here cos 2 theta is equal to 2 cos square theta minus 1. So after solving this, we get this one, z to the power 4 plus 1 upon 2z square. Now we will put the values of cos theta and cos 2 theta in this equation. Okay. After putting these values in the equation, we find here z to the power 4 plus 1 upon 2z square upon these values, and we also solve d theta. We know that d theta, यहाँ से we can solve it. dz is equal to iota e की power iota d theta. So d theta is equal to dz upon iota z. So we replace d theta here. D theta replaced by dz upon iota z. Okay. After solving these, we find this equation. This become 1 upon 2 iota integral along C z to the power 4 plus 1 upon z square into 2z square plus 5z plus 2 dz. Okay. So factor this. After factoring this one, we get 2z plus 1 into z plus 2. Okay. So here is the function fz. Z की power 4 plus 1 upon z square into 2z square plus 5z plus 2, and this function has pole at z is equal to 0. Here z is equal to 0 of order 2, and z is equal to minus 1 by 2 and minus 2 are other poles of the function fz. But minus 2, this pole is outside of the contour. This is outside of this function. Minus 2 does not belong the contour C. Therefore, we consider only 0 and z is equal to minus 1, which is inside the contour C. Okay. Now we will integrate this function. Therefore, 1 upon 2 iota integral of fz dz along C is equal to, by Cauchy residue theorem, we know this become 2 pi iota into residue of the function at z is equal to 0 and residue of the function at z is equal to minus 1 by 2. Okay, so first of all, we have to find the residue of the function at z is equal to 0. Okay, residue of fz at z is equal to 0. As we know, this become limit z approaches to 0, differentiation of z square, that is z minus z naught. Here z naught is 0, so z square into fz, this is fz. Okay, cancelling these and differentiating this function, we get this one, and putting z approaches to 0, this become minus 5 by 4. Now we find the residue of function at z is equal to minus 1 by 2. So this become limit z approaches to minus 1 by 2, z minus z naught, that is minus 1 by 2. So this become z plus 1 by 2 into fz. This is our function. Cancelling out, we get this one and putting these values. So after all, we find 17 by 12. Okay. Now our integration is integral along C fz dz is equal to 1 upon 2 iota. Here we can see 1 upon 2 iota into 2 pi iota into residue of the function at z is equal to 0 plus residue of the function at z is equal to minus 1 by 2. So this becomes minus 5 by 4 plus 17 by 12, and after solving this one we get 2 by 12 pi, that is pi by 6. Okay, thank you.